Hey everyone, this is Bhargav Sudhar, and today we will learn about types of lattices. Now in this today's session, we will learn some types of the lattices, properties of the lattices, and some of the examples. Now first let us understand the properties of lattices. So let A less than or equals to B a lattice. Okay, so the first property, that is the idempotent properties. So what does it means? So this A or A equals to A. Now what is this symbol or? So or means that is the least upper bound. Fine. So A least upper bound A equals to A. So that means the least upper bound of itself, that is A. Now in same manner, the greatest lower bound of the same point, that is itself. Now second, associative property. So what does that tells? So A or B or C equals to A or B or C. So that means this or means what? It is the least upper bound. So A least upper bound, B least upper bound, C. So it means that we can change the brackets. Okay, so it is associative. Now in same manner, the greatest lower bound, for greatest lower bound it will hold. Okay, so then next, that is the commutative property. So A or B equals to B or A. What does that mean? We can change the order of the greatest lower bound or least upper bound. So we can change, if we want to find the LUB or GLB of two numbers, then we can interchange the order and the answer will be same. The next, absorption law. Now what is absorption law? So just it's by name, this A and B. So that means lower bound. So greatest lower bound of AB, whatever the answer it is, and A greatest lower bound, this bracket. So it is A. So that means this A is absorbing this answer. Fine. Now in same manner for least upper bound. So it will be same. So that means this A or B. So that means least upper bound, LUB of A and B. So this A is absorbing this bracket. So that is the absorption law. Now let us discuss types of lattices. So the first type is this bounded lattice. So let us understand. So let A less than or equals to is said to be a bounded lattice. Now we know what is a lattice. So if the greatest element and the least elements are in A, fine. So if the greatest element is denoted by this I symbol and the least element is denoted by this O symbol or 0, then for every A belongs to A, this A is in between the 0 and I. Okay. So in short, the greatest element and the least element are in the given set. So then we can say that it is a bounded lattice. Also, this A or 0 equals to A. Now see, this is the least element and this is whatever the A it is. Okay. So A and 0, and this symbol means what? It is the least upper bound. So LUB, now least upper bound of A and 0. Now this is the least number and we want to find the least upper bound. So the answer will be A. Now in same manner, A or this I. So that means now LUB of this greatest element and some element. So as it is the greatest element of the whole graph, so that means the answer will be I. Now then this A and 0. So that means to GLB. So greatest lower bound of A and 0. Now 0 is the least element and the greatest lower bound. So it will be 0. Now in same manner with the greatest element, if the greatest lower bound, so it will be A. Fine. Now for example, so just consider the poset, this P of S and the subset. It is a bounded lattice. As why? Now this P of S, that is a power set of S, and this is a subset relation. So as this phi belongs to P of S, so it is the least element, and also S belongs to P of S. Now what is S? That is the whole set. So it belongs to P of S. So where this S is the greatest element and phi it is the least element, so it is a bounded lattice. And here this for every A belongs to this power set of S, and this A is a subset, this A is in between phi and S. Then also just that four conditions, this A union phi equals to A, phi is the least element, so A union phi equals to A. Now in same manner, this A union this greatest element, so it will be the greatest element. Fine. Then next, now come to intersection. So A intersection phi, so that will be phi, and A intersection the greatest element, so that will be A. So this also holds. So fine. So this is the example of a bounded lattice. Now let us discuss what is a distributive lattice. So a lattice A less than or equals to is said to be a distributive lattice if for any elements, just take three elements, that is A, B, C belongs to the set. A, this first condition. So that means this A and B or C equals to A and B or A and C. Now this AND means what? It is the GLB, and this OR means LUB. Fine. So GLB and LUB. So it is nothing but it is the distributive property or distributive law. And in same manner, if we change the order of LUB and GLB, so this two condition has to hold. Fine. Note. So if A less than or equals to does not satisfy this distributive property, then it is known as non-distributive lattice. So it is just a lattice with the distributive property. So it is called a distributive lattice. Okay. Now, for example, determine whether the following is a distributive lattice or not. Now, this is the Hales diagram that is given. Fine. So now, see, first step. For distributive lattice, we need to check this distributive properties. So just consider 3 points. Fine. This A and D or C equals to what? So that is the left hand side of the distributive property. Now A and D or C. Now this is what? D or C. So where is D? Now as you can see that this is the least element and this is the greatest element, and rest are the elements. Fine. Now D or C. So where is D? That is D and C. Now that is the least upper bound. Now what is the least upper bound of D and C? So that is D itself. Now A and D. So that means greatest lower bound of A and D. So A and D and the greatest lower bound. So it will be this A. So this is the left hand side. Now right hand side. So that is A and D or A and C. Now A and D. Now A and D. Okay. So what is A and D? So N means lower bound. So greatest lower bound. So greatest lower bound of A and D. So that will be A. Fine. And greatest lower bound of A and C. So A and C. So it will be this O. That is the least element. Now A or O. Okay. So that means now A least upper bound of O. So A and O. So that is A. Fine. Now you can see that this left hand side and right hand side both are same. So that means it holds the distributive property. Now consider another 3 points. That is A, B and C. So now B or C. This B or C. So that means least upper bound of B or C. So that will be I. So that is the greatest element. Now A and I. So that means lower bound. Greatest lower bound of this A and I. So that will be A. Fine. Now again same manner right hand side. So A, B, C. So A and B. So that is A and B. So A and B. So that means lower bound. Greatest lower bound of A and B. That is A. Now A and C. This A and C. So that will be O. Now A or O. So that means least upper bound. This A or O. So that will be A. Now as you can see that this is left hand side and right hand side. Again they are same. So that means they are equal. Fine. So hence it is a distributive lattice as it satisfies the distributive property. Now let us discuss another type, that is a complemented lattice. So let A less than or equals to be a bounded lattice. Okay, so it has to be a bounded lattice. Now with the greatest element I and the least element O. So and then let A belongs to A. Okay, so an element this A dash belongs to the same set is called a complement of this A if this A or A dash equals to I. So that means this least upper bound of A and whatever the A dash. If least upper bound of A and A dash is I, so that means the greatest element. And same manner A and A dash. So that means A and A dash. So and this means what? It is the lower bound. So greatest lower bound of A and A dash equals to 0 or O. Fine. So that is the least element. So and a lattice is known as a complemented lattice if it is bounded and every element of A has a complement. So in short, it has to be a bounded first and then every element has a complement. Fine. So that is a complemented lattice. Now let us discuss example. So the question is, show that the given lattice is a complemented lattice. So this is the example. Okay. So for complemented lattice, all we need to check that it has to be bounded and then it has to each and every element has a complement. Fine. So here A or C. So that means A and C and the upper bound. So that means least upper bound of A and C. So that is I. Fine. And this A and C. So A and C. So that means greatest lower bound of A and C, that is 0. So therefore this complement of A is C. Okay. Fine. We are just checking those two conditions. Okay. And then let us consider B and C. So B and C. So B and C's upper bound, least upper bound. So that is I. and B and C's greatest lower bound, so that is O. So as you can see that this B and C, they are also complement of each other, so that means complement of B is C and complement of A is C. Fine. So therefore the complement of C are what? The complement of C are A and B. Okay, so that is correct, and that means every element has a complement. So as you can see that C's complement is A and B, and A and B's complements are C, and I's complement is O. So that means every element has a complement, so hence it is complementary lattice. Thank you.